NA engines, it can be super critical to get good ring seal. Turbocharge, I think everyone knows once you get over a certain point, that thing's breathing no matter what you do. The catch can's going to be full no matter how good you think you're at honing, or if you've done the hot hone, or you just can't keep that cylinder sealed up.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Tom Hughes from Hughes Race Engineering right here in New Zealand. Tom goes through his background, explaining how he formed an interest in cars and, more specifically, engines, before getting an apprenticeship with a race engine builder. We talk a lot in this episode about the differences between building garden variety road car engines and the skill set and attention to detail required when it comes to building competitive race engines. Following his apprenticeship, Tom also did a stint working for Rocket Lab here in New Zealand, building, of all things, rocket motors. He then transitioned into starting Hughes Race Engineering, running his own shop, and we talk about the dedication and leap of faith required to go from steady employment and actually take that leap into starting your own business. He's now built a great name here in New Zealand for building some of the fastest and most powerful Toyota 1UZ based superstock engines. And we'll find out what a superstock engine is and what the rules and limitations are around building them. But he's not a one-trick pony, and he shows that the skill set that he's built up can be applied to building any engine. So for anyone interested in building their own engines, this episode is going to be a banger. Before we get into our interview with Tom, for those who are fresh to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune performance engines, both factory and aftermarket engine management systems. We also cover motorsport wiring, harness construction, race driver education, race car setup, and a number of other topics. All of our courses are delivered via online video-based training modules that you can watch from anywhere in the world, provided you've got an internet connection. You can find a full list of all of our courses at hpacademy.com/courses. And as a podcast listener, you can use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. I'll put a link in the description to make that super easy to find. Also, if you like free stuff, I've got a great deal for you. If you head to hpacademy.com/giveaway, every month we run a different giveaway. It could be engine building tools, it could be an ECU or a dash, but it's always a great deal and it's absolutely free to enter. So head along to hpacademy.com/giveaway and get your name in the draw. All right, enough of that introduction. Let's get into our interview now. All right, welcome to the podcast, Tom. Thanks for joining us today. And as we always do, let's start by getting to know you a little bit. Specifically, let's go into your background. How did you first get involved in the automotive industry or cars in general?
Grew up racing motocross, so that kind of gave me a bit of a mechanical background, working on bikes since I was 7 through to I was about 20. And then cars come on board when I got my license when I was 15. First car being a KE30 76, and the first kind of car project was putting a 4-age in that.
Right, so you really jumped straight in with your first car.
Yeah, I've still got that car now. You might have seen it on our social media. It's got a 3SG beams in it at the moment.
Very nice. I've still got a very large soft spot for old Toyotas. Unfortunately, old Toyotas are exceptionally good at rusting as well, so it's really, really hard to find good, clean examples of cars of that age now.
Yeah, for sure. That's had a lot of love to that thing now.
No doubt. All right, so it sounds like, at least beginning with the motocross, you're already learning a little bit about the mechanical side of working on bikes. Obviously, a lot of that translates to cars. At this point, before you sort of started your working career, how were you learning these skills? Is it sort of from friends and family, self-taught? Yeah, what's the go there?
Yeah, definitely growing up working on bikes. Learned a lot doing that, like from a young age. Servicing them, doing pistons on them, doing clutches, and that's from when I was about 10 through to about 15 doing all that. And then left school and got straight into an apprenticeship when I was 16 at an engine building. So I was lucky enough to get a job straight into the industry, which I kind of always dreamed of, being kind of mechanically minded. And then spent 6 years at that business doing a automotive machining apprenticeship.
Okay. What was it about the sort of engine side of things that drew you in as opposed to maybe going down a more conventional, just mechanical apprenticeship?
I think it's just how intricate, and I love everything being perfect, and the idea of working on an engine, like nothing, it's like the pinnacle of engineering for me. It's just like an engine is where you put all your energy and all your time to make it perfect, where sometimes working on a car, depending on what level you're at, it doesn't have to be perfect, so that's where the engine side comes in.
Yeah, close enough is good enough is not really a term that's thrown around in too many race engine workshops, that's for sure. I'm guessing as well, sort of the background that you had with the motocross, as you mentioned, sort of doing pistons, which people who haven't had any involvement with motocross maybe wouldn't understand, that's quite a common or frequent occurrence, isn't it? Sort of rebuilds of the engine to keep it running how it should.
Yeah, especially growing up in the two-stroke era, doing a rebuild every 15 to 20 hours, if you're pretty serious on a top end, is standard. So that's started on a 65 through to 85s, 125s, and then once you go on to a 250, it's a little bit more serious, but that's kind of where you start learning a bit more, especially now working on four-stroke engines. It all started there.
Sure. Okay. So a bit of crossover even with the differences clearly between two-stroke and four-stroke. In terms of the apprenticeship process that you went through, can you give us maybe sort of a high-level view of what that apprenticeship is and what's involved in learning all of the various skills that you needed?
Yep, so it was an automotive machining apprenticeship. That's everything based purely on engines, which was cool. Depending on what shop you work in is the opportunity you get to learn different subject or different. You might learn about camshafts, you might learn about cylinder heads, you might learn about boring and honing. But as a whole, it was purely just based on building engines. Most of it is reconditioning based. Not a lot of it's race engine based, but at the shop we were at, we did a lot of camshaft grinding, so that was a big part of it, and that's quite an intricate process. So it was cool to be able to do that through there.
In terms of the differences between a regular engine reconditioner versus those who are more sort of focused on performance and race engines, this is something sort of that often comes up in our podcast chats. What differentiates those two styles of engine machinist?
You shouldn't compare them, that's for sure. There's such a big difference between someone that might be servicing a diesel, say rebuilding diesels or rebuilding like a conventional road car, versus what goes into building a race engine that's going to be really leaned on and really pushed. Can get away with some things, probably more so in a road car that you would never get away with in a race engine, be it clearances or quality of parts or reusing a part that you shouldn't reuse. So knowing what a high level build is versus throwing an engine together, say, this isn't poo-hooing an engine reconditioning at all, but you can't take that mentality to building a high-end race engine, especially when it's worth so much money, and expect it just to run fine, basically.
Yeah, no, I absolutely agree. I just wanted to sort of get in there. There is a distinct differentiation between the two tasks. And as you mentioned, we're not trying to knock an engine reconditioner. They're just doing what is, on face value, seems to be the same job, but with significant differences when you actually get down into the nitty gritty. And particularly when you mention clearances there, are we talking about the fact that the range of clearances that would be acceptable in a garden variety road car engine versus what is going to be acceptable in maybe a 1,000+ horsepower race engine needs a little bit more fine tuning and attention to detail?
Yeah, so that just comes down to how intricate are you going through this build? Are you checking everything? Are you checking bearing taper, run out of different components? That like everything needs to be measured, checked, and then written down and logged, because if an engine is getting leaned on that hard and it comes apart for a rebuild or it has a failure, you need to know exactly where everything's at, so you can either amend it or change the parts or do something to make it better. Whereas a road car, you can be surprising, what an engine can take sometimes when you see what comes apart in a conventional road car that's had a hard life, and what the abuse they can take when the clearances are a little bit bigger and everything is a bit easier lifespan for it.
Absolutely, yeah. So over the time you're working in this race shop, how did your sort of skills progress? And what, obviously, when it comes to race engine building and development, there's a lot of areas that sort of need to be understood, a lot of different skills that have to come together in order to get the right result. What is it about your sort of background there at that race shop during your apprenticeship that you sort of enjoyed the most? What aspects of the engine building process did you really enjoy the most?
So that shop was primarily based on building the 1UZ engine for a class of racing in New Zealand. It's a rules-based engine, so it was always very competitive. One, for the class of racing; two, between engine builders around New Zealand who can have the most powerful engine and who can be the most competitive. So based on that, you're constantly looking for more out of the engine, whether it's in port design, camshafts, components, short block components. Everything was change, intake manifold, exhaust. So it was a very cool shop to be a part of because we're constantly changing. It was never just like the same old parts coming through. It wasn't just machine, hone, assemble, out the door. It was always, okay, what are we doing this year? What's the upgrade this off season? And that's kind of where the base of my engineering came. And it wasn't just an engine building shop. We did fabrication and a lot of other things, engine testing. So yeah, it was a cool place to be.
Yeah, it sounds like a perfect place to get that broad range of skills and understanding of everything that goes into it. Now, obviously, at this point, you're running your own shop. At what point did you sort of decide the time's right, let's make the leap, let's actually start something for yourself?
So I thought about this when I was very young, that I wanted to start my own business, just because I guess who you are as a person kind of determines that and how motivated you are. And I kind of held off because I got an opportunity to move to Auckland and work for Rocket Lab, the New Zealand space program.
Oh, okay.
So I spent 3 years building the engines for them, and then just the time was right and I met the right people. A workshop came up, and then I said, sweet. So I ended up staying at Rocket Lab and then kind of doing HRE on the side for about a year, just in the weekends, after hours.
I think we need to just dive back into this whole Rocket Lab thing, though, a little bit more. So I guess for those who haven't heard of Rocket Lab on the other side of the world, I guess it's close-ish to Elon Musk's SpaceX in terms of what's being done. Obviously a little way behind in a much smaller scale. Would that be sort of a fair way of describing it?
Yeah, it was a New Zealand startup, and I was there reasonably early. I think I was number 68 employee, so that was quite a small team, and there was a lot going on, but on a very high level in New Zealand, which was really cool. So the raw way to put it is just a New Zealand space program, a mini version of SpaceX, if you don't want to offend too many people by saying that.
Sure. I'm trying to sort of not show my ignorance here because I don't deal with a huge amount of sort of space rockets in my day-to-day, but I would have thought that the rocket propulsion would be somewhat different to normal internal combustion engines. So what are you actually building? What engines are being built for these?
Yeah, it's like you can't compare the two at all. Obviously, it's all engineering at the end of the day, but there's definitely no pistons in a rocket.
No, not a lot of oxygen to burn naturally up in space either.
No, and it ran on liquid oxygen and kerosene, so two fuels that you don't see in a race engine. Maybe you use kerosene to wash an engine, but you don't necessarily use it to run. But what we did there, that team, and what you were exposed to every day, the engineers and the clever people, and it was a very, very fast pace when we started, so it was a cool place to be.
Yeah, no doubt. No, it sounds really interesting. All right, so you started HRE sort of as a bit of a side gig. You sort of mentioned that you already had this aspiration to own your own business and run it. How difficult was that step to take, though? I mean, a lot of the people I talk to who have started their own businesses, that first jump where you're already in employment, you've got a paycheck coming in, you know when it's going to come in and how much it's going to be, that jump into the unknown is very difficult for a lot of people to take. So how did you get over that mental barrier and take the plunge?
Yeah, for sure. I was like massively tunnel vision. I was obsessed with starting a business. So I ended up selling my house and using that money to fund the workshop, basically. So I was still at Rocket Lab. I sold my property that I had for a few years, and I used that money to buy machinery, set it all up, and basically deck the workshop out, and also use that money to build a project engine, which was the original 1UZ we built for the shop that we put in a car. And this was all funded by me, just purely to get exposure. And this is while I was working at Rocket Lab and doing this, because I knew I had to do something. I couldn't just turn up and say I build engines. So the whole idea of developing that One UZ platform and showing so much on social media and putting it in a racing series in New Zealand was to get exposure and show that we could build some cool things.
Yeah, because of course, as you mentioned, you're in a controlled class there, and there are a number of engine builders in New Zealand building these 1UZ FE engines for the superstock class. So when people want to go competing, they're going to look around at who's already winning and probably put their money on that particular engine builder. So you can't just come out of nowhere, as you say, and start getting work. So I see that being a sensible way to start promoting yourself. I mean, the obvious question is, how did it perform?
Yeah, that went really well. So I played around for maybe 6 months developing that, and I had some close friends who raced in that class who was willing to let me put it in their car. I still owned all the engine and built it all myself, and he was a really competitive race team. So he was able to run that for 2 seasons, had some really good wins with it, won amateur champs and World 240s and all these things, which was a huge bonus for me, because being able to run a race engine in a car, understand what's good and what's wrong with it, and feedback from the driver, and then have results was pretty cool.
Sure. And I'm guessing here you're also kind of hitting the ground running because your experience through your apprenticeship was essentially developing this same engine. So without sort of conflicting with intellectual property, etc., you weren't kind of starting from zero with developing the engine, were you?
No, I spent basically 6 years building 1UZ.
So you know them inside and out.
Yeah, I was really comfortable. So it was a great engine to start. Obviously, I wasn't picking up something completely unknown. But in those 3 years, it was amazing how much the product that I was building had changed, because that class developed so much. And what I thought was fast, I built the first engine, and it wasn't a dud. It was good, but the second version we built was completely different. So it was a massive learning curve. But yeah, you're right. I wasn't just going in green and like, let's build an engine, because that's a really difficult engine to build, and a naturally aspirated engine for a class that's restricted is super involved.
Yeah, and I think, just if I look at my own experience, I've kind of almost exclusively built turbocharged engines. And while, yes, of course, just like any engine, if you want to beat the rest of the world or get the most out of a turbocharged engine, you still absolutely need everything to be working in harmony. But there is a level of boost is kind of a great way of fixing shortcomings in other areas of the engine, whereas when you're dealing with a naturally aspirated engine, you've essentially got nowhere to hide. Would you agree with that?
Yeah, definitely. And turbo technology is so good that it masks an average engine potentially. Like, you can have a stock 2J and make a massive amount of power efficiently because the turbo technology is so developed. But then an NA engine, everything has to be perfect, from the intake, runner length, and on that class they run a carburetor, so you've got the issue of trying to make that work, and the camshaft profiling, port design, from the squish bands on the piston, everything is critical.
Yeah, there's a lot going on there. Okay. We'll get into the 1UZ FE and your development process shortly, but let's just come back to starting HRE. You mentioned, obviously, selling your property in order to fund the machinery. So how did you decide, how deep you're going to go down this rabbit hole? Were you going to set up a fully fledged, fully functioning machine shop, or was that not feasible financially and you had to sort of pick and choose what equipment you were going to have in-house versus what you're going to outwork?
Yeah, so it definitely wasn't a fully functioning shop, but what I did, I basically thought, what do I need bare minimum to build race engines, whether that be measuring equipment, tooling. I bought the generic kind of things like mills, lathes, surface grinders. You need cleaning. It's a massive, painful part of building engines, so you need a good cleaning facility. All that kind of stuff adds up, and that's what I did to start with. Bought little things like valve refaces, rod hones, little equipment that's not super expensive but very important. And then from there, once I started getting more work, then the workshop kind of developed, and we bought some more machinery so we can do more in-house.
So you still do rely on outsourcing some of the mission-critical machining operations?
Yeah, definitely. So the main 3 things we get done outsourced is boring, honing, and align honing, which are super important to any engine, and everything else, cylinder head wires, seat cutting. So we've got a head shop, milling of blocks and heads. We've got a dedicated surfacer for that. And that kind of covers everything top end wise, and then obviously short block is a bit harder. The machinery is so expensive for the one job it has to do, so it's a big investment to spend $100,000 on a machine that's just going to bore one hole, for example, for a boring bar, or you go CNC and buy something which could be $250,000, but it's just built for doing short blocks, which is awesome. Like that'd be the ultimate goal. But in New Zealand, we're very much limited to how much our customer base. So you can't kind of buy this machine and hope the work just comes from nowhere.
Yeah, I'm guessing if you want to invest in equipment like that financially to make it viable, you're really going to need to be punching engines through that machine literally one after another, 5 days, 6 days a week, right?
Yeah, for sure. And people who are overseas listening, New Zealand is a really cool place. We make high-end products, but it's so small and relative to Australia, and then you can't even compare us to the States. So there is lots of shops, and we are very competitive, and I think we're good engineers in New Zealand, but we do not have the market to have these wild workshops.
Yeah, which is unfortunate in a way, but I think the New Zealand or Kiwi mentality has always been to do more with a little, because really a lot of the time we have no option. To give our listeners maybe a bit more of a sense of scale, could you give us an idea of how many engines are coming out of your shop in a year?
In a year, it all depends, but basically I've since starting HRE, I've got like a serial numbering system. This gives you an example. So every number is serialized, and we write down everything, clearance, everything to do with the engine, what camshafts are in it, cam timing, tappet clearance, what size shims. It's all logged and written on the computer. And our database is pretty much at 100 serial numbers. That's 100 engines, and that's over the last 5 years. So that's an average, you could say. Some of them are complete builds. Some of them might be a cylinder head job, but that's how much work we do. And for a long time, I was working by myself. I've had someone come on in the last 2 years, so there's two of us. Get a surprising amount done for two people. But yeah, if we had another person, get a lot more done, but it's a big risk to take, as you know, to take someone on when you're at that growing point, and
definitely
you want that, make the extra step.
I would have said 100 engines over 5 years for something as niche as what you're doing is pretty good numbers, actually. Particularly most of that time was doing it all by yourself, so that's pretty impressive. Now we've got a bit of a sense of that scale anyway. Just coming back to sort of the machining side of things, because this is a question that just crops up so frequently, particularly home enthusiasts who want to assemble their own engines, and at that point you're obviously reliant on outsourcing all of the machine work. You obviously can do some of it at least yourself. And the question that always comes up is, how do I find a machinist that can work at a race engine level, as opposed to what we were talking about earlier, the sort of garden variety road car level? Have you got any advice you can give us there to make sure that when you do hand over your hard-earned cash to a machinist, you're actually getting the results that you want?
Yep. So components are really, really good, well made now. So you buy a rod, a piston, all these parts are so well made, so people feel like and get away with building engines at home. But that's, like you said, it's the point where you hand something over to a machinist and it's a bit of an unknown. You've got to have a massive trust with them, because if you can't measure it properly because you're not experienced enough, that's kind of where the holes start to, the pattern kind of falls apart, and your race engine build that should have been easy is now really difficult, and you've got problems. So for us, when I first started, I was very experienced in obviously automotive engineering and machining, but I didn't have any equipment. So taking that first step of building a relationship with my machinist, who I use now a lot, it was hard, but you have to have the knowledge to ask the right questions and get good answers. If you're going in there green and you're trying to get something machined, it's a hard path to take. You can't really avoid it. That's why there's engine builders, I guess. And as much as people want to screw things together themselves, there's a lot of research that goes into something simple, and people do get away with it. People can assemble an engine and be like, look at this, I assembled it, I made 600 kilowatt. But if that one component wasn't right, or if that one bearing had a little bit of taper that you didn't pick up on, that could be $20,000 just Chernobyl in front of you. And that's the difference, I think. That's the difference of someone who's a hobbyist and has built a few engines and they're an engine builder. And that's cool, it's still fun. Like, I don't poo-hoo having a hobby, but the difference of missing a couple of tenths here and a couple of tenths there, and then all of a sudden you've got something that just doesn't want to run, basically.
Yeah. I mean, I think you definitely can't overlook or underestimate the attention to detail that is required to assemble a race engine and get the right results. The other element which comes, this is where it gets a little bit grey, I think, sometimes when you're dealing with an engine machinist, is enthusiasts or hobbyists, if you want to call them that, tend to think, I'll give all my parts to the engine machinist, they're going to come back perfect and all I have to do is clean them and put them together, job done. The reality, and I stress this quite heavily through our courses, is, in my opinion, the responsibility always is on the person assembling the engine to assume nothing and double check everything. So what I mean by this is, just because you've gone to a quality machinist, I mean, sometimes even the best machinist has a bad day or might overlook something, or whatever it may be. And it's your responsibility to double check all of the measurements, all of the clearances as the engine is actually being assembled, to pick up on these things. And if you don't do that, even if it's the machinist that's made the error to start with, obviously there's some responsibility there. But if you put that engine together, start it up, and it fails as a result, I still believe that it's the person that's assembled the engine that really should put their hand up and take responsibility. How do you sort of feel about that?
Yeah, for sure. So everyone thinks that engines are these perfect things, because they do need to be very perfect. But the whole time when you're building an engine, you're taking calculated risks when it's going together. No, that sounds weird, but nothing is ever perfect. Like, you want it to be perfect, but like you just said, you have a machinist, you have parts that get manufactured, and once it gets all in front of you and you put it all together, depending on how particular you are, you're taking calculated risks. Okay, that's going to be okay. That's going to be okay. At this clearance, it'll be okay. That needs to be modified. So that, like you said, it's a big part of it is exactly that. It's understanding the parts well enough that you can, this engine requires that much clearance, or if you go below this, it's not going to like it, or whatever else. So yeah.
I think probably I've been a little fortunate in that the engines that I've dealt with and sort of the era when I started building engines, I think the quality of the factory engines that we're dealing with, as well as the aftermarket components, which you kind of alluded to before, were already at a very high standard. I mean, I don't have first-hand experience with this because I haven't built older engines, but I hear horror stories about the quality of the factory machining in maybe old small block Chevs, etc., engines of that era or older, where there was potentially core shift when the blocks were cast. The deck surface of the block in factory form wasn't maybe parallel to the sump rails, etc. All of these things that actually needed to be corrected when the engine was built. Whereas, we look at a modern, maybe Japanese engine, the factory engine is already really, really good. So there's less of that goes on. Again, do you sort of agree with that?
Yeah, well, that's what I was saying. Japanese engines, which most people and what I work with pretty much basically all day, they're so well made. So they're so good over their engineering. And then the part quality that you can buy off the shelf now, if you pay good money, you will get a great quality part. So that's why people can assemble these engines in their garage, and they go good, and they talk it up to the right spec, and they throw some race bearings in, and that's great. But it's that's the last 10% that you might miss. That is where you probably find your problems, and that could be a small problem, or it could be a massive problem.
Yeah, unfortunately, it doesn't take too much with an engine when it's maybe spinning at 8,000 RPM and producing 500-600 plus horsepower. When you have a problem, generally it's going to end up being a very, very expensive problem, which is sort of the name of the game, why we want to get it right in the first place. Now, sort of a term that we often hear thrown around in engine building circles is the term blueprinting. And I don't know, I guess my personal opinion is that it's misused a lot and maybe almost lost a little bit of its relevance at the street level. Certainly with what you're doing, this becomes a lot more important. But can you give us a bit of a rundown on that term blueprinting, what it actually means and what it sort of refers to in terms of the building process?
So blueprinting is more so, that's like you said, it's kind of thrown around now. Blueprinting is checking everything to factory tolerances, but if I blueprint an engine, it's my engine, so I might blueprint it to my specs. And that means checking every component is within your tolerance or the factory tolerance, depending on what you want. just like I said before, like we document all our builds and check every single clearance. So that for me, that is blueprinting. It's checking everything, it's logging it, and it's understanding exactly what's in front of you and making sure that you're happy with it. It's right for the application. It's right for that type of engine. Because again, every engine could be slightly different. If it's an RB, if it's a 2J, if it's a 1UZ, turbocharged, NA. So for me, blueprinting is exactly that. It's going through and it's measuring bore size, it's measuring tunnel size, bearing thickness, like what tape is on a piston, like how much clearance am I giving this? The recommended clearance is this from the manufacturer, but we're using it in a slightly different application, so we're going to give it this. It's very much, for me, that's what blueprinting means, but it's purely based on blueprinting something to within factory tolerances.
Yeah, but those factory tolerances, of course, become almost irrelevant when you're starting to take an engine and make double the power that the factory expected and maybe rev it another 1,000 RPM past the factory red line, correct?
Yeah, for sure. Yeah.
Okay. I just want to come back to one of the pieces of equipment you mentioned before, and that's a line honing. For a start, for those who haven't heard that term, can you give us a quick rundown on what that means and what that piece of equipment is used for?
So it's used to true or line hone a main tunnel in a block. So the engine caps that come on that get bolted down to the cylinder, to the block, obviously come through with bolts, and the tunnel is supposed to be perfectly round. But if you go put aftermarket caps on, they won't align because the hole needs to be perfect. If you put a stronger bolt, like an ARP bolt on there, it will pull the tunnel out of round because you've got more tension coming through the cap and the block. And the machine basically puts through a big mandrel with stones on it, and you flick it through back and forwards, and it aligns everything perfectly true. So when the crank goes in, the bearings go in, everything in theory should be true to each other.
So this is like absolutely sort of bare bones basics essential. If that main bearing tunnel isn't true, isn't on the correct size, basically all bets are off, correct?
Yeah, if you've put an aftermarket bolt in it, chances are it's not round, and if it's done 100,000 Ks, chances are the core or the casting could have slightly moved. So there's a lot that goes into making sure that is true. And obviously, if you put a billet main cap on, or you're changing to that extent, then you've got to bore the main cap back out and then hone it after that.
I think most people could probably understand that moving to a billet main cap, which is pretty common with a lot of engines. SR20 is one example. The 2JZ is another great example of an engine that really needs billet main caps after you get past a certain power level. So, I mean, that I think would go without saying that that's going to need to be done. But the bit I think probably a lot of people would overlook is that when you go from that factory bolt to an ARP stud, for example, which would probably be, sort of engine building 101 these days for a high-spec street engine or race engine, that can actually distort the tunnel. So is that always the case? And by what I mean by this is every time you put an ARP stud kit into an engine, is it absolutely going to distort that main tunnel, or is it more prone to do that with some particular engines and others you can get away with it? Interested on your take on that.
The term get away with is great because you may get away with it, but it all depends on that engine. So I guarantee there's people listening, but like, I put ARP main bolts in my 2J and torqued it up, and it's done 10,000 Ks, and you're probably right. It might have, but just like I said, if that 10% doesn't line up, it's a major. So everything we put ARP bolts in gets a line honed, and the more you do, the more you understand what they need. So you might know that an RB moves this much when you put a bolt in, a 2J moves this much, an SR might move more than you think it does because they're an 11 mil stud, and all these things add up. So just dropping a ARP bolt in, especially to a main stud, you might get away with it, but I wouldn't suggest it.
Yeah. Again, it just really comes down to you're not taking risks, and that's why a professionally built race engine costs what it costs, because there's time and labour and machining artwork that goes into it. While we're talking on that subject as well, just to sort of give an example, the Subaru EJ series engines, probably FA as well, but I mean that's a classic where if you use an ARP main bolt kit, obviously the two halves of the block bolt around the crankshaft in that style of boxer engine, and you torque those up to ARP's recommendation without the align honing process, you literally will not be able to turn the crankshaft. That's how much it distorts, probably not aided by the fact that it's an alloy block. And before someone gets up in arms in the comments, I can't say that's going to be the case for every engine, but certainly I've seen that with my own eyes. It's definitely a problem. So that highlights the extreme of how bad it can get. And I mean, obviously, you couldn't even finish assembling the engine in that circumstance because you can't turn it over. So it's a pretty big red flag. But I mean, if it wasn't quite that bad, you could still turn it over. Maybe you sort of didn't notice that it feels really tight and it's not quite how it should be. I mean, that engine's probably not going to last 5 minutes once you actually start it, correct?
Yeah, that's a good example because they are a major to get right. I don't know if you've played around with those before, but one thing is getting them true and then getting them to the right size. Because it's an aluminium block, you've got a very small tolerance or window you want it to sit within, because when it's hot, that thing's going to grow a lot. So you want it super true and you want it quite tight when it's cold, because when that thing grows, you might see it grow 1.5 hours. So you've gone from 1.5 vacuum clearance to 3, and then you lose all your oil pressure because you've only got a wet sump system that can't keep up. And then all of a sudden you've got problems you didn't know you had. You don't know where they're coming from. So there's little things like that can get you.
That would probably be a fair element with an alloy block versus a cast iron block anyway, with the different thermal expansion coefficients, in that you're going to generally be setting the clearances a little tighter in an alloy block than you would in a cast iron block normally.
Yep, always. Aluminium blocks, and just like you said, with the EJ being alloy casings both sides, they'll grow a lot. A billet block, for example, will grow a lot, but even an aluminium block with like a Honda K series with a cast-in cap on the cast iron cap and the bed plate side, they still grow a lot. So aluminium can catch you out massively.
While we're sort of talking around clearances as well, what do we need to take into consideration when we're building an engine that's going to be making more power and maybe revving to a higher RPM than factory? I mean, obviously for every engine, it's relatively straightforward to source the factory workshop manual. They are going to give the clearances that they recommend, as well as sort of a maximum that you can run to. So if you've got that factory clearance range, how are you deciding what to change that clearance to with a higher performance race engine? Or does this sort of come from trial and error, building the engine, running it, getting it back for a freshen up and seeing how everything's looking inside?
Yeah, so like I was saying, material is a big part of it, and then application. And if it's like a dry sump system, if you've improved the oiling system of a factory, you might be able to get away with more clearance without, with the oil pressure dropping off when it gets hot. So you've got to be aware of that. Some people will say, more clearance won't cause an issue, but that's not necessarily a good thing, because you've got more oil flow through the engine, the oil will get hotter. If you've got big main clearances, you won't get as much oil pressure to the big end. So all those things add up, and factory clearances are normally quite tight because they're made to start up and drive down to the dairy and get some milk. They're not really made to race around a track full noise for hours on end. So as a rule, race clearances will be bigger, but they won't necessarily be as big as you might think they need to be.
Okay. I mean, the other element that sort of plays into this as well is it's going to depend, I will assume here, on the specific engine that you're dealing with. If you are dealing with factory components or factory-based engines, there's likely to be more flex in those components. Let's say a factory crankshaft versus a very high-end aftermarket crankshaft. That crankshaft's possibly going to flex more at high RPM and very high power levels than a really good quality race crankshaft, and that will also drive your clearance requirements.
Yep, that's true. And then also a big one would be a connection rod where the bearing caps are. Like, most people probably wouldn't be aware that a race bearing is oval. It's not circle, or most bearings, and then a race bearing has more oval to it than a conventional bearing that would come out of a standard engine. And because the rod is flexing so much that they pinch on the surfaces where the main cap sits, or the rod cap sits. So things like that you've got to be aware of. So if when you're checking things like bearing clearances, and a rod, for example, it's always pays to know what your side clearance is. So you know that if that engine is going to be a 9,500 RPM engine, you know that thing's going to flex a lot. You know the rod size, and that's a big thing in Toyota V8s. Because they're a V8, they're quite a narrow rod. So you need to make sure you have enough side clearance for the rod to breathe, as you call it.
Yeah, interesting. That's something we haven't really discussed on the podcast before, but great information to have there. In terms of the other machine, and just coming back again to machining, one of the sort of critical elements with getting a good ring seal is the hone process, which sort of puts that crosshatch pattern onto the bores and allows the rings to bed in and seal properly. There's a variety of different equipment available for that boring and honing process. In your experience, is the more modern CNC honing equipment giving a better finish and hence a better ring seal than older manual equipment?
Yes, if you're doing everything else correctly at the same time, though. So if you're honing with a torque plate on to the right torque, for example, you've got a machinist who is doing a good job. There is a CNC hone, like a Sunnin, for example. They're still manual driven for 50-50, say, like it hones, but that you still got to drive it quite well at the same time. And then it's how much attention the person on the machine is paying, and it's a big factor. And then if you want to get really into it, you'd be like, oh, well, why don't we run a hot hone? We've got the thing at full temperature and we're honing it because the bores are only going to distort when they get hot. So it's something you can't measure unless you do it that way.
Yeah, I wanted to actually touch on that exactly. So it's good that you brought that up. I mean, I think most people who haven't really dealt with this would assume that the bore is round and that it's parallel from top to bottom. But even before we get into hot honing or torque plating, the end result of the hone is going to have a big, will be impacted by how that hone is used, in terms of it's very easy to end up with a bore that it got belling in it, so it's not parallel top to bottom, correct? So you can have an area where it's wider and narrower.
Yeah, so you'll be surprised when you take, like you said, for a torque plate off, depending on the engine and how strong the head studs are. If you take it off and you measure it, you'd swear the machinist has done a poor job, because you're like, this thing's massively out. It might be pinching at the top or halfway down, might be like barreled out. And then you put the torque plate on, which is the same as having a head on, and everything becomes true again. But then there's also the massive unknown of what's happening when this thing is hot. When it's at 180, or this is depending on what you're running at Fahrenheit or degrees, or 180 for the States, 180, 200 degrees Fahrenheit, then what happens to this bore?
So the hot hone process, as its name would imply, is running hot fluid through the water jacket of the block to basically replicate the conditions the engine's running in when it's out on track. So if you're boring and honing, or honing under those conditions, theoretically, if the operator's doing their job properly, you should have the best chance of getting a perfectly round, perfectly parallel bore that's going to do the best job possible of giving ring seal when the engine's operating.
Yeah, so that's exactly what it does. And as well as that, it would have a torque plate on at the same time that it's hot honing. But in some cases, if you do an aluminium hot hone, you can't, because you'd hot hone it and you'd take it off and it'd cool down and you wouldn't be able to get the piston in the bore. So you have to be quite careful of what you're doing. It only works in some applications.
That was going to be my next question. Obviously, the block is going to grow as it heats up. So if you're aiming for, I don't know, a 4th piston to cylinder wall clearance, for just an example, cold at room temperature, maybe 20 degrees C versus 80 degrees of water temperature, they're going to be completely different numbers, aren't they?
Yeah, massively. So as cold as it is, it's sometimes you got to close your eyes to the unknown, because you can't fix it. Like NA engines, it can be super critical to get good ring seal, and sometimes you'll find that overboring an engine and having really thin ball cylinders will cause a bigger problem than you think. You don't know you've got a problem until it gets hot. Turbocharge, I think everyone knows, once you get over a certain point, that thing's breathing no matter what you do. The catch can's going to be full, no matter how good you think you're at honing, or if you've done the hot hone, or you just can't keep that cylinder sealed up.
It's going to flex no matter what you've done.
Yeah, exactly.
Very difficult to put specifics around it, but just for our listeners, a conventional block that's just been bored and honed, no torque plate, no hot honing, versus the same engine that's been torque plate honed, hot honed, what would the difference that you're going to see in ring seal? Could you convert that into maybe what that would look like on the dyno in terms of power? Are we talking 3 to 5 horsepower over 500, or are we talking sort of 10 to 20? How substantial is it?
Arguably on a turbo engine, like you said, it might be 20 horsepower at 600 or 700 horsepower at that range, but it's a really hard one to put a number on. It's ticking boxes, you can tick. So when you're doing it, you're like, right, I can do this right, so I'll do it right, and that's the best process there is. So a lot of that comes down to when you're building an engine, that's how you got to build it. So you're not just going to close your eyes to it because it's an unknown. You kind of just make sure it's perfect, all you've done, and then you kind of step back and go, sweet, that's right, and then this is the end result.
Controlling the things that are within your control realistically.
Yeah, exactly that.
Okay, so the torque plate, we didn't really touch on the torque plate. I'd assume that most people listening probably know what a torque plate is, but you kind of alluded to the fact that it's a plate that's bolted to the block during that honing process to replicate the cylinder head being bolted in place. And the reason we do that is because when the head's bolted in place, it's likely, almost certainly going to distort the bores. So again, it's all about just getting the bores true and round when the engine is actually assembled and running. Now, another element is that we can sort of see a similar distortion on the cylinder head in terms of the valve seats. The valve seating is really critical, that the seat is contacting perfectly on the valve when it's closed. And when the head's machined, that's fine. But again, when the head's bolted onto the block, often things can move around on that front. I know there are some people who are using essentially a torque plate for cutting valve seats on the head. Is that something that you've found to be useful, or is that again on a case-by-case, engine-by-engine basis?
It's definitely case by case, but an example of that is in the RBs we build that are normally well over 1,000 horse, and they have like a 12mm stud in them, and you torque them up, depending on what you want to torque it to, 110 foot-pound, for example, and you do a leak down test on it, and you'll swear something's wrong because number 6, number 1 will be leaking because they're unsupported and the valve seats distort that much that all of a sudden your perfect valve seat job we've done on the bench is no longer perfect in the engine. But in saying that, does it cause a problem? Somehow it doesn't, but you get this, like, you can make it right. You can put a torque plate on it and torque it down to the full torque of what you're going to see in the engine. But then when you do that, you also have to set the tappets, because if you set the tappets for a head that's not torqued down, if the valve seats are moving that much, then the tappet clearance is changing. So it's a never-ending circle of like chasing your tail to make it perfect. But yeah, there is options there that you can make it right.
And I find as an engine builder, it's very difficult to sort of turn a blind eye when you've assembled the engine and you do a leak down test on it and find that you've got leakage past the valves. Like, very difficult to sort of send that out the door in good faith and sort of have that, I'm sure it'll be all right attitude. It's sort of, one of those things you just don't want to see. And when you do see it, I kind of find it has to be dealt with, correct?
Yeah, correct. And did you find that with your Evos you built over the years?
I didn't actually have too much trouble with the Evos. The example that stuck in my mind, or two of them, one is a 2JZ that I built, and we found that problem with valve leakage with the head torqued down. And again, we were using ARP custom H625 bolts, so you can really get some torque into those. And it's not unreasonable to expect things to move around, but again, it's one of those things, unless you check it, you don't know what you don't know. The other one was our SR20 race engine, and we were advised at the power levels we were aiming for not to upgrade to a larger head stud, because the experience of the company that we use for doing our head porting was that the larger head stud creates so much distortion that the valve seats will be distorted and you're going to have that leakage problem. So at the point we're at with that, it's not really an issue and we can keep the head on it. But I mean, obviously as power levels and boost levels rise, it becomes more of a problem. So I guess we'll cross that hurdle if we ever get to it.
So with our RBs, just on that again, we only do our head studs. We use like you said, a 12mm stud, custom age ARP bolt, but we're only doing up to around 95 or 100 foot-pound for this reason, and that's running 50 pounds of boost, because if you go to the 140, everything moves in unmeasurable amounts. So unless you really need to seal that head and you're having massive head gasket issues, which isn't a thing of the past depending on what engine you're working on, if you're running a fire ring or something like that, just be aware of the problems you are causing by throwing this cool, very expensive stud in this engine.
And I think that is another one of those areas where those who haven't actually got experience with these products, you get your new stud kit from ARP or whoever you're dealing with, and you pull out the documentation and it says whatever it might be, 120, 140 foot-pound of torque. So, I mean, obviously, well, that's what we're going to do, without understanding the knock-on implications of how much that's going to distort the bores, how much it's going to crush the cylinder head down. And I mean, even when we get aside from the distortion of the valve seats and the leakage that can create, the other element which I've sort of seen is you almost get the head bowing between the studs. So what you're doing is bolting the head down with more torque in order to hopefully improve your head gasket seal, but you're actually almost bowing the head away from the block in between the studs and kind of almost making the situation worse. So, yeah, I think there's levels to this, and kind of as you've mentioned there, using the bare minimum is really what you want to do, and this really then gets a knock-on of, what is your head gasket sealing technique, because that plays into it just as importantly these days with some of the head gaskets that are available, getting away from MLS and going to maybe the likes of an aluminium bronze sealing ring with a copper gasket, which is most of the people running these very, very high boost drag engines have gone to. That means that you don't need necessarily all of the clamping force that the stud can provide. So again, there's a lot to learn, and a lot of this does come from experience as opposed to just purely going off what ARP say in their directions. I think that's probably something that's worth getting out there. I just wanted to take a moment to interrupt our podcast here, and if you have been enjoying our chat with Tom so far, and maybe you're thinking, hey, you know what? I do want to take that next step with my project build and have a crack at actually learning how to build my own engines, then we've got a perfect deal for you. That is our practical engine building course. We've got a special deal here. You can use the coupon code HUGHES50. That'll get you 50% off the purchase of that course. And this course is designed to teach the average home enthusiast who's got a little bit of patience and an eye for detail how to build quality and reliable performance engines. It isn't based on any specific engine. It is generic because the skill set, as we've found with our chat with Tom so far, is essentially applicable to any engine, provided you understand the process of building engines. We know it can be a little bit daunting though, understanding what to do first and what order to progress in. So what we've done within this course is broken the entire engine building process down into the HPA 10-step process. By doing this, each of the individual steps is relatively quick and easy to complete, and in no time you've got to the end, you've got a completely assembled engine. You're going to have the confidence that all of the parts, the clearances and the tolerances inside that engine are perfect for your application. So when it comes time to start the engine for the first time, it's going to start up and provide great power, great torque, and most importantly, great reliability. Once you've learned the fundamentals and that 10-step process, this course moves into a library of worked examples, which is where we get a little bit more specific, dealing with a specific engine building project. You can watch the entire 10-step process being applied in real time from start to finish to really expand your knowledge. Now remember, you can use the coupon code HUGHES50. It'll get you 50% off the purchase of that course. We'll put that coupon code in the show notes to make it super easy to find. And remember, you are still protected with our 60-day, no questions asked money-back guarantee, so absolutely zero risk getting involved. Let's get back to our chat now. Now, moving on in terms of the development process of the engine, let's sort of deal with that 1UZFE because obviously it's your staple and you know it inside and out. What is the process that you go through when you're trying to sort of develop the engine season on season, and you've already got a very developed starting point? How is it that you're managing to still extract more performance out of the engine?
So it always comes down to the opportunity you get with your customers. So if you've got good customers that are willing to push the limits of the class and they want to be competitive, is always a big bonus. And then it comes down to just thinking outside the square. So if you've got the time of the season to try different camshafts on the dyno, try different carburetors for that class, port design, you might be like, all right, I was in the flow bench and we decided to stop here because we thought we had enough air, or maybe we could even go to a smaller port, or maybe we could change the valve size because we think we're shrouding the valve against the bore. So you get to a point where you improve, but then once you have to improve again, somehow you manage to find something else. So that's the cycle of a restricted class, and that's what keeps it so interesting.
Yeah, okay. Let's get a little bit more clarity around the specifics of the class. So limited to 4 litres, from what I understand, and 10-to-1 compression plus a control. Is it a control carburetor? Is that kind of about right?
Yeah, it's about right. So it's just over 4 litre as the class rules, and then the carburetor isn't restrict. Like you can use whatever carburetor you like, whatever size, whatever brand. So that's fine. And then the compression ratio is obviously 10-to-1, and the valve lift can't be over 500 thou.
So in terms of analysing that 1UZFE with those rules in mind, for a start, where are the strengths and weaknesses in the 1UZ?
So that engine is in New Zealand. There's probably about 200 or 250 superstocks probably running around New Zealand, and I'd say 70% of that class, or probably 70% of that class, is all 1UZs. So that gives you an idea of how popular and how well the engine suits that class of racing. One, you're starting off with a well-made Japanese engine that's readily available, which is a big bonus. So if something goes wrong, you can easily replace a block or a head or something like that. And that engine is well over engineered in different areas with the crankshaft and the block and the 6-bolt mains and all those things that just pretty much scream rev me up and I'll be fine, because that's very, very cool. And the forged steel crank standard and all these things that add up to be a very easy engine to modify. Obviously when you start splitting hairs it gets a little bit more difficult, but they're just so well made, and they've been developed in New Zealand for so long. For the last 25 years, that engine's been run. I think in the late 90s, early 2000s, that engine kind of first came into that class of racing. It's when they become more of a wrecker engine after the late 90s or mid 90s, when the engine was around a few years and you could buy them from the wreckers and whatnot. Before that, the class was kind of more 2-valve Chev and Ford based. Then people started realizing we could use these Toyota V8's, and then that's why they're so heavily developed in New Zealand, because for so many years we've been using them, and so many people have been using them. It's not just like one or two people have been developing the engine. There's 200 people developing this engine every year that want to get more out of it.
Yeah, definitely. How many engine builders are there in New Zealand developing the 1UZ for that superstock class?
There'd be 6 or 7 engine builders on different levels. Obviously, some of them have more engines out there than others, but there'd be at least 7 guys that are doing a good job of it. And then there's also the small workshops that rebuild them and tinker with them on the side.
I'm guessing that also drives the whole industry, because if you've only got maybe 1 or 2 engine builders, the rivalry is maybe not quite so intense, but when the numbers start getting up and you definitely want to get the work, obviously it's important that your engines are making the most power and torque, correct?
Yeah, for sure. And then,
or at least winning, I should say. Really, that's the key in the end.
yeah, you got to go out and win. That's what people want to see, and it's a hard class to win. Like it's super competitive. It is like one of the most competitive motorsports in New Zealand, and one of the biggest and most followed. And to go out and win is really, really, really difficult. And you can have a hot rod engine and obviously still not win, just like any kind of motorsport. But an engine is a big part of winning that class. You can't go out there 100 horsepower down and think you're going to go and clean up everyone. Realistically, you need that edge. You need that final piece of the puzzle, which could be the engine, or could be your setup, or could be whatever it is. You got to make sure that all those boxes are ticked.
And in terms of horsepower and RPM range, can you give us some idea of what your engines are producing?
Yep. So that class being a single gear class, so you've got first and second, but first is kind of like, they call it a pit gear. So you're starting first and hook second, so you stay in second gear the whole lap, meaning that you need a real broad power curve. So especially in traffic, being such a busy class and a contact class, you need about a pull from 4,000 RPM right up to say 9,000 RPM, which makes it hard to build because NA engines obviously love to rev, but you need to keep in mind that this thing needs to have a nice broad power curve. You need to be able to roll it off the turn, put your foot down, and then go right to the end of the straight. Power-wise, they're about 540 horsepower at the flywheel, so that's probably like 450 at the wheels, and that's with all those class restrictions as well.
Yeah, sure. That is a really broad rev range that you've got to make that engine perform. I assume there's a lot of compromise that goes into the cam profile, cam design, and the porting to make it not just a peaky engine that's only really working up around sort of 8,500 RPM and does give you that broad rev range.
Yeah, for sure. And especially a carburetor, you want, like a smaller carburetor is obviously going to be more responsive. So you need that response to pick up fast, because being a contact class where you can drive into someone and push them out of the way, you want to be able to blip the throttle and have that thing instantly respond. And then you can push that person, as crude as that sound, out of the way and then dive for the next guy.
I mean, I've heard the term rubbings racing, but that's that's taking things to a whole nother level.
Yeah. If you haven't gone and watched superstock racing, or even if you're overseas, just go online and search New Zealand superstock racing and watch like a late video from the last 5 years, and you'll be blown away. And if you want to see something really, really scary, watch teams racing.
What happens with the teams racing? I'm almost scared to ask.
So it's 4-on-4, and they're in a team each, and it's a full contact class, which even if you say it's a full contact racing class, you don't even understand what that means. Dirt track like anything else, like a sprint car, but it's got concrete walls around the edge, and it's full contact basically. So there's rules. You can't be ridiculous, but you can pretty much wind someone off the end within reason, full noise into the wall, or hit them parked, or in teams racing it is.
Okay. I'm probably I'll stick to my road racing, I think. Safer.
Yeah. I raced for 2 seasons. It was just hard with the business and everything. I ended up selling the car because I was too committed to making that work. But that's a real eye-opener when you go out there. Like, it's super fun. It's like motocross on 4 wheels, and it hurts a lot. I'll tell you that much. When you hit the wall, it hurts.
Yeah, I can absolutely imagine.
Yeah.
All right, let's come back to the engine. In terms of competing engines, as I understand it, the Nissan VK56 is another pretty popular alternative, although again, as you mentioned, limited to a touch over 4 litres. So these, as I understand it, de-stroked to meet that capacity rule. Obviously the VK56, a newer engine design in comparison to the 1UZ, and quite different in terms of their architecture, with what is essentially a proper twin cam cylinder head versus the sort of scissor drive arrangement that Toyota use on the 1UZ. And if people don't understand what I'm talking about here, if you're not familiar with that, maybe just Google that 1UZ cylinder head and get an idea. Essentially, there's only one cam gear at the front of each cylinder head, and then the other cam is driven off a gear arrangement off the other cam. Terrible way of explaining it, but again, a quick Google will clear that up. So can we get an idea of the pros and cons of that VK56 versus the 1UZ? Who's sort of come out on top of that battle?
The 56 is a real competitive engine for that class. It has, obviously, it's a little bit later model, so it's got some bonuses in the head and things like that, like you said with the valve train layout. But again, a very expensive engine to make, because you've got to start with a custom crankshaft, so straight away, and it's not like a custom crankshaft that you might buy for an SR. This is a real custom Bryant crankshaft, so they could be anywhere from $8,000 to $10,000 for a crank. So that's a big expense that you've got to be willing to pay before you even start anything else. So then, depending on what bore and stroke combo you want, you might have to put custom liners in it. So they are a cool engine, but they're a very expensive engine to make. Again, why the Toyota is so popular. If you wanted to, you can go racing with a Toyota on a reasonable budget. No racing's cheap, but it's a lot easier to go racing with a Toyota.
I guess even aside from the custom crankshaft to de-stroke it, even the entry price for a VK56, I haven't looked recently, but it's safe to assume significantly more than a 1UZ.
Yeah, for sure. Yeah, the entry price, Toyotas are coming up a lot, just like anything Japanese at the moment, and that kind of heritage era is getting expensive. But the 1UZ is also, it's got the 2 different models, which are both used in Superstock class. The VVTi engine, which is the later model, like the LS400, is the pick of the class now, just because it's a little bit better everywhere. But going back to the scissor gear thing that you said, although it's driven off one camshaft, it's still a quad cam. It's just a
Yeah, I mean, maybe when I said a proper quad cam is maybe not quite the term that I should have used. You're right. Clearly, it is a quad cam engine, just a slightly different drive arrangement. I mean, I can assume that cam timing with that style of cam drive would be a little bit more challenging than a conventional quad cam engine. That's the term I should have used, a conventional quad cam engine.
Yeah, for sure. So with the VVTi engine or the 1UZ VVTi, we machine pretty much everything. And in that class, you're not allowed to use variable valve timing. So I've got our own blanking plate that goes on there, and then we get the standard scissor gears machined, so they now have adjustment in them. That gives you the option to cam time it to wherever you want, intake and exhaust on both sides. But it's a bit of a process being 4 cams.
Yeah, no doubt. My stance on variable cam timing is I absolutely love it, and it, particularly for a stock engine or a lightly modified engine, it does genuinely give a massive improvement in the torque curve. And it's interesting because when we were just starting to see VVTi engines come into the mainstream in the aftermarket, and the ECUs that were available from aftermarket manufacturers at the time obviously didn't support variable cam control. And I remember a few of the ECU manufacturers were basically trying to say that it didn't matter and you'd run it without the VVTi because it was really just for emissions. But, only a year or two later, when we started seeing support for variable cam control, it became pretty apparent very quickly how much torque you were leaving on the table if you didn't use it. But when you start modifying the engine and using larger cam profiles, which don't give the ability to swing them as much without risking valve to piston contact, the variable cam control becomes less significant. The other element is when you've got a conventional road race car with maybe a close ratio sequential gearbox, your rev range that you're actually using on track becomes so narrow that the variable cam control becomes less relevant. But in your application, if you were able to use it, going from 4,500 to 9,000 odd RPM, I would imagine that even with a very large cam, the ability to move it a little bit through that rev range actually would be beneficial.
Yeah, if we could use VVTi in that class, it would be huge. To be able to move the cam timing even a few degrees, as you see it hugely on the dyno. When we're dyno testing and we move the cam timing around to try to figure out what the engine likes, 2 or 3 degrees, you'll definitely see it. And if you go like extreme, like 10 degrees, it's like it'll ruin the engine pretty much. So, or obviously fix the engine.
Yeah.
So to be able to move it 5 degrees would be huge.
But of course, the rules are the rules, and everyone's stuck with the same rules. So I just wanted to get that in there about the potential with the variable valve timing. With the power that these engines produce, obviously with naturally aspirated engine, as we've already kind of talked about previously, you have to have everything, all the ducks lined up in a row to get the results out of the engine that you're expecting. But one of the key elements with the performance of any engine really is around the flow through the cylinder head. What is the process that you go through with porting these heads? Are you doing the porting in-house yourself? Is it hand ported? Is it a CNC port job?
Yep. So with that 1UZ platform, we developed that port for the VVTi in-house, starting on the flow bench with a standard port, standard valve. You kind of get a base with the standard cylinder size just to see where it's at and what potentially you could do. So the first thing you do would be to go to a bigger valve, which necessarily straight away you'll have a nicer valve seat cut because you've got more area to put a nicer cut on it. So normally you'd find a gain there instantly, and then you need to find out if you can go bigger without shrouding it next to the cylinder wall. And you just go down rabbit holes of, does it want material removed here? Does it want more of a bowl around the back of the valve? Do we need to take material out in the runner, especially with this class being a single gear class that needs a broad power curve? You don't want a port too big and lazy because it's not going to do what you want it, right across the power band. So that's a starting point. And then the exhaust is similar. Check it standard, find out what the restriction is. Is it around the valve seat? Is it exit area? Is it around the valve guide, the window beside the divider? And yeah, you slowly take material out.
I mean, just sitting here listening to you explain all of that, I'm kind of just going through in my head how many iterations you must have gone through at this stage to get your engines to where they are. How many would you sort of guess at that you've gone through?
Yeah. Well, I think just the first time we were on the flow bench for 2 days, and you can test quite a lot in 2 days, but that's, like I said, you're testing it once, taking it off, cutting a valve seat, putting a different valve in it, and you might go, sweet, that's that flow bench number, and then we'll put a 55-degree back cut on that valve and see if it does anything. So you go around in circles to gain 2 CFM, but standard, I think they flowed like 260 CFM, and leaving the standard runner size, so the standard port size where the intake manifold goes on right down to where the divider is all stock. Just with putting big valves, moving material around behind the divider, it's up to just under 300 CFM, so 298 CFM. So it's a big difference over standard.
Yeah, that's substantial. Head porting is one of those areas that I haven't got into myself. I kind of see it as one of those areas where there really is a bit of an overlap between sort of art and science. How reliably can you take the numbers off the flow bench and then kind of know when it actually comes time to go on the engine dyno what that's going to look like? Do they correlate nicely, or are there often sort of surprises in terms of, I think most people would probably understand that bigger isn't always better, which you kind of mentioned before?
Yeah, so especially in an NA engine, they're very sensitive to small change. Where a turbo engine, you might remove a lot of material, but your restriction could be the turbo, or it could be, something stupid, something you can't control for that class. But with the NA engines, they're so sensitive that if you take too much material out, you might lose torque or gain horsepower, or you might gain torque and lose horsepower. It comes down to doing it enough times that you understand what's the safe amount to start with, and then testing it and getting a result that makes sense to what you've done. Because many times you can do something and have a problem somewhere else that's restricting the gains you could be getting, or dulling down the losses that you are getting.
Kind of masking what's actually going on, in other words.
Yeah.
In terms of the hand porting versus CNC porting, how much of a problem is it? I mean, one of the obviously sort of advantages that is claimed with CNC porting is the consistency across all of the heads that you port, and I guess even consistency from cylinder to cylinder versus hand porting. I mean, the reality, how much of an issue is that really?
Consistency, I would say, would be zero if you're a good porter. The time it takes to port a head is massive. That is where CNC is just incredible. Just how fast you can port a cylinder head and how much you can charge out is a lot less than hand ported. Some ports favour hand porting just because how they're cast and the core shift and things like that around the valve seat. Maybe the CNC won't clean up, or maybe just to clean that up with a CNC port, you have to take too much material out just to make it look pretty. So CNC is great, but it's not a CNC port you're paying for. You're paying for the hand porter that did it the first time right.
Yeah, I mean, that something had to be digitized to create that CNC program, correct?
Yeah, exactly. But everyone thinks just CNC is great, but it's only as good as the programmer putting it in. So it's not always the case that CNC port is just the bee's knees, just regardless. Not poo-hooing CNC, it's great. Definitely that's the way.
But and it's another one of those cases of garbage in, garbage out. So you need the good hand-ported profile to digitize in order to get a good quality CNC result.
Yeah, exactly. And then, like I said, in certain cases, a hand port might work better because you might want it to be exactly stock through the runners, but you might want a small amount taken out of the bowl to get some good gain. So that might be what you're going to do for that application.
Sure. All right. Another element there with this super stock class is that control 10-to-1 compression ratio, and I think most people sort of understand that within reason, more compression is going to be beneficial to us. What could you get out of these engines if you had freedom with compression ratio? And then that leads into a bigger question, where is the sweet spot in terms of choosing a compression ratio when you have to factor in the quality of the fuel, the octane of the fuel that you've got available to you?
Yeah, just like you said, with the octane of the fuel is huge. Like if you can have a really good quality race gas, compression's your friend. But if you're on a pump gas that might not necessarily like it, then that's not a great start. As far as the superstock engine, if you were to say go 13.5 to 1, That's one advantage. But when you've got bigger compression, you can use bigger camshaft profiling. Because the engine has got more compression to use, you can get away with a bigger profile. If we were to put a really big profile on a 10-to-1 compression engine, it would be a lazy mess of a thing. But if that same engine with those same camshafts was 13-to-1, it would just liven the whole thing up and everything would work in harmony, basically.
Right, so it's just another one of those sort of knock-on effects of the compression ratio affects other elements of the design of the parts you're choosing.
Yeah, exactly. It's about how much efficient cylinder fill you can get, basically. And when the camshafts suit the compression, it's great. And when they don't, you're fighting.
Yeah, in terms of sort of where the limitation comes in, I mean, let's take octane out of the equation for the moment. So we're building an engine that we know we're unlikely to be knock limited on. But do we get to a point where, the more compression you try and build into the engine, you've got this big, ugly dome on the top of the piston? Does it get to a point where that dome is actually getting in the way of the flame front propagating through the combustion chamber and actually negatively impacting the combustion performance? So while, yes, you've got more compression in the engine, it's actually working worse than if you went with lower compression and had a more efficient combustion process going on?
Yep, definitely. So you've kind of got to get, like you said, octane out of it. You've got to get the most efficiency out of the fuel and how much energy it has. So it will get to a point, if I could tell you this point, I'd probably be a lot more successful, but you get to a point where you'd have so much compression that the engine becomes inefficient. So the engine cannot crank, you cannot compress that cylinder enough to get the energy back the other way out of it, if that makes sense. You still got to compress that somehow and use it efficiently and obviously expand the fuel and then push it back the other way. So if you were 20-to-1 compression ratio somehow, and you had to compress that cylinder upright before the flame front started, then you're probably going to start going backwards because you can't actually run it that hard.
Sure. Okay. Yeah, so I mean, it's not a case of just more is always going to be better. How about when we've obviously talked so far about the 1UZ? However, I know that you deal with a range of other engines. You've kind of already mentioned a couple of times the Nissan RB. When you're starting to deal with a turbocharged engine, obviously less compression in a turbocharged engine has always been the way. Over the decades that I've been involved in the industry, you've sort of seen the compression ratio for turbocharged engines creep up though. Earlier days, probably sort of 8-to-1 or even in the 7s was pretty commonplace for a turbocharged engine. Now we're seeing the likes of JE, Wiseco, CP offer off-the-shelf pistons in the sort of 9.5, even 10-to-1 compression range for turbocharged applications, particularly when you're starting to use good fuels like E85, for example. Have you got any sort of data points on how the compression ratio works in a turbocharged engine and whether I guess the question is, are we better to stay lower on the compression ratio and use more boost or vice versa?
Just like you said, I think fueling over the last 10 years or so has been a massive part of it. Having E85 fuel makes a huge difference versus a pump gas that maybe isn't that flash. As far as compression ratio goes, having a higher comp and running lower boosts, they're kind of each to their own. You can go either way. And then you also comes into it, you being a tuner would be able to explain this better, was how much ignition time you can run versus boost pressure versus how much temp the engine's creating, and all those things go into it. But as far as we do, it's like our bigger RB engines over 1,000 kilowatt all run about 8-to-1 compression ratio, but they're running like 50 pounds of boost, and yeah, they seem to like it that way.
I'm assuming at that point you're dedicated E85 or a proper race gas?
Yep, it's a proper race gas. They have seen them made just under 1,000 horsepower on pump gas though.
Yeah, definitely makes your life a lot harder. I mean, I think these days there's going to be a generation of tuner come through that will never understand the difficulty of staying away from detonation on a high boost turbocharged engine, almost of any compression ratio when you are running on a shitty grade of pump gas. E85 has dramatically made our lives easier in terms of making more power, and is also, again, kind of comes back to what I was saying earlier with turbocharged engines. You can make up for a lot of downsides with your engine design just by adding a little bit more boost, and that fuel kind of, again, just gives you a bit of a free kick in terms of you can run a lot of boost with a lot of ignition timing, often tuning to MBT without the onset of detonation. I won't say that it's impossible, but definitely it's not as common. Coming back to the RB versus the 1UZ, obviously completely different engines in there in every way, shape and form. From your perspective, do you get more enjoyment and satisfaction out of your 1UZ program compared to your RB program, or have they both been equally satisfying and challenging?
The RB has been cool because we're in a pretty, it's a cool era to be in as far as RBs go, because a GDR is now worth so much money now. So people are willing to spend X amount on, making these real nice cars. Nice sequential gearboxes in a street car, for example. 1,000 horsepower is like the standard in a street car, basically. So as well as the era being ruined for a lot of us, that now you can't afford the GDR or whatever it may be, but it's a cool era to be involved in building them. So that's what makes the RB so cool, because there's such an elite engine now. If we build an RB, most of the time, if it's an RB30, you might start with a donor RB30 block, but every component is brand new. So the cylinder head, the crankshaft, piston rods, valves, it's all completely brand new. So that makes those builds awesome, but you can't beat developing a rules-based engine, which is constantly evolving and super competitive. That's really interesting.
Yeah, I think the rules-based, you've straight away got the ability to measure your success against those other 5, 6 or 7 workshops that are creating the same rules-based engine, whereas even in the super competitive RB drag racing, roll racing world, I mean, yes, you're competing against other RB engines, but you absolutely know that the spec of that engine is going to be maybe different capacity, different pistons, different rotating assembly. The cylinder head's going to be different. It'll probably have a different turbocharger. So it's never an apples with apples comparison, is it?
No, it's exactly. When you're lined up for roll racing, which is slowly growing in New Zealand now, it's who's obviously got the most power and can hook it up the best is going to win. But every engine combination is completely different. Like no one's working even in slightly in the same ballpark, which is fun because you're not limited to any restrictions, so you can kind of just get as carried away as you want to. But as you know, you can build a short block and a long block so strong, and then it's who can slap the biggest turbo on and wants the biggest lag.
I mean, that really, when you get down to the nuts and bolts of it, though, is really almost what it does come down to. Yes, I'm oversimplifying it, but a lot of it really does come down to the turbo selection. And while, yes, the cylinder head and the cam profile is important to get the airflow through the engine, really beyond that, it's just, can you build the engine to be strong enough to support the cylinder pressure that you're going to create in order to make the power that you want? And the rest sort of goes without saying. Would you sort of agree with that?
Yeah. There's still learnings like when you're building them. Recently, we did a full new cylinder head for JT Performance with his 40 PSI GDR. And we changed all the squish band and the port design and throats through the back of the valve, and we went in the right direction and probably gained close to 50 kilowatt on the same boost pressure. But at the same time, I think now it's just turbo limited. So if he wants to put a bigger turbo on and sacrifice, not spooling till 6,500 plus RPM, then he can do that. it'll hold together.
That'll be the next step, and it'll make more power. Moving on, there's always a difficult, or sometimes a difficult relationship between an engine builder and ultimately the person that's going to be tasked with tuning the engine. I've been in that situation myself, because as a tuner, you sort of end up being the last person to touch the engine. And often if something goes wrong, fingers are pointed, be that rightly or wrongly. That sort of ends up being the way it goes. How do you find that relationship when you're relying on others to tune the engines that you're building?
Yeah, that is a hard one. So most of the time, if we have a new customer come on board and they are looking to build something serious, or regardless of what they're building, there's always a few questions you ask them. And the first thing is, like, who's building the car, who maintains it, and who is your engine tuner? Because if you don't trust that person straight away who's going to be looking after the engine when you've let it go, then it's not a good start, and that could, end up going the wrong way, or things just happen. So that's the kind of first thing I like to clear up. And then if they ask, or if they say, who would you like to tune it, I can give them some options depending on where they live and who they're friends with and all that kind of carry on. But it's definitely an important one to have. I'm really close with JT Performance. because of what we've done with him over the last few years with the GDRs, and he tunes a lot of the drift engines that I build.
So you've sort of built up some trust there that he's capable and understands what he's doing.
Yeah, for sure. And he tunes a lot of our drift builds. We build a lot of engines for the drifting series in New Zealand as well, the D1. And it's just nice knowing, and for him, nice knowing when the engine turns up, he knows it's going to run right. Because as you know, there's nothing worse as a tuner hooking it all up and going through this process and booking a day out, and then something stupid happens, and you're like, well, thanks. And you have to disconnect it. And then who do you charge? And you know.
I mean, I think that the relationship does go both ways, because you're exactly right. I've had numerous situations where we go to start running in a freshly built engine that's been built by who knows who, and you sort of start the thing up and it's a sprinkler system. It's spraying oil, water, and maybe, God forbid, fuel everywhere. So straight away, that's the end of it. So yeah, the relationship does go both ways. Likewise, the engine builder, you want to protect your reputation. To do that, you need a tuner who actually understands what they're doing, so you can trust that they're going to actually look after the engine and give the engine what it wants. So A, it can produce the numbers that it's capable of, and B, it's going to do that for a long and healthy life, I believe.
Yeah, you want that trust when it goes out the door, and trust with the customer as well. So the engine tuner is great, but then the customer, you got to understand that they've got enough knowledge that when they're assembling it, they're not going to drop a bolt in the intake and all of a sudden who put the bolt there, or it's just stupid things like that. Like, or if you send an engine out and it's got no sump on it because they didn't have the sump ready in time, and then they've got to screw the sump on and the pickup doesn't go on, something like that can easily happen.
Oh, there's numerous ways to have sort of things go sideways that you can't predict at the outset. So yeah, absolutely. This is sort of probably a good segue into warranties on race engines, which is always a controversial topic. What's your stance on that, and what should a customer be able to expect from one of your engines, and where's the sort of line get drawn? Because at the end of the day, it is a race engine. It's being used in a fairly high-stress motorsport application.
Yeah, it's a tricky question, and it comes down to the relationship you've got with your customer. But normally there'd be you call it a limited warranty, where you warrant all your workmanship. You warrant your workmanship basically. So if something goes wrong that is blatantly your fault, like something's not done up or something's in backwards, or that's workmanship error. So you have to cover that. You cannot question that. If something fails, that's a hard one, because sometimes you can buy an aftermarket part that is the best part, but it still might fail. A valve head might break off, or a camshaft has a problem wearing in and it rips the camshaft up, or something stupid like that. So that's where it's a bit of a grey area. But at the same time, if this person's come and spent good money with you, and the easiest option is for both of you, maybe, okay, you supply the faulty part and I'll fix it for free within reason. There's no way to compromise both ways, because one, the customer needs to understand they are playing with race cars and race engines, which is fun, but it's expensive and risky. And I'm an engine builder, so I've got to take that risk at the same time.
Yeah, it is a tough one as well, because the cost when things do go wrong, I mean, if it's a catastrophic failure, you literally could be walking away with no usable components from the engine. So hence recovering that, no matter who's sort of shelling out their hard-earned, it's going to be a big wad of cash. So it's a difficult one. At the same time, obviously, again, comes down to protecting your reputation, and dealing with the customers in good faith, I think, is always important if you want to have a long and healthy career in this industry. There's too many that I've seen come and go where it's a one-way street. They're quite happy to take the money off the customer, but when things go wrong, all of a sudden the customers get ghosted. And I think that's the sort of business that kind of gives the whole industry a checkered reputation. So I think, dealing with your customers in good faith and doing the best you can, I think is really important. All right, Tom, let's move on towards wrapping this thing up, and we've got the same 3 questions we ask all of our guests. The first of those, what's next in the future for you in HRE? Are you in a growth phase? Are you wanting to build this company bigger? Are you going to start moving into parts manufacturing? What are your options, and what are you considering?
Yep, so always growing pretty much since I started. We've always been growing slightly. As far as what's next, the engine side of it is going really well, so we're always going to continue to do that. And whether that be buy more machinery so we can do in-house, depending on how much work we come in, that's going to be the next step there. And then as far as, like, just funny you mentioned part manufacturing, because that's something I've been super interested in, is making HRE parts, engine parts for certain type of engines that we kind of specialize in. So we actually have some projects coming out recently that will be able to showcase some of that, and been working on that for the last kind of few months. It's been a slow process, just keeping all the engine customers happy and trying to grow that. But yeah, there's definitely some things coming out in the not so distant future with HRE, which will hopefully give us more of a global customer base.
Can you give us some insight into what some of those parts might sort of be?
Yep. So I would really like to get into making engine building specific tools. So tools that are to certain engines, things like that. And then as far as components go, depending on what market we get into, just your generic like 2J RB parts, your bolt-ons and things like that. So
I mean, I think that's smart because obviously when you're building engines, they're very labor intensive. So you're kind of limited in terms of how many hours there are in a week to what you can do. Whereas if you're starting to produce parts, you can make these in mass, and much easier to ship a relatively small component across the world from New Zealand rather than a complete engine. So, like you mentioned, that broader reach to the larger world is probably going to be a good way of expanding the business, I would assume. Next question, is there any advice you'd give to a younger version of yourself to help reach where you are today in your career faster, or potentially maybe avoid any pitfalls that you've come across?
I think the way I did it has worked out really well. Obviously, it's going great. I think the biggest thing which helped me was being super receptive to everyone I meet. So that, I wouldn't say what I would change, but I think that's what helped me the most is everyone I've talked to, no matter if you think they're not that, like, the brightest person, or you think they're no help to you, listen to what they have to say, because even if they have one thing good to say, you can take that and it might be the missing piece that you need. So being receptive has been cool, and it's allowed me to meet a lot of cool people like yourself, like being able to talk to you over the years. I've talked to you a couple of times, not much, but having a loose relationship like this that, one day I might need, and I'd like to, if I could help you with something one day and you can help me, just things like that.
Yeah, I think this has come up as a fairly common thread through the podcasts that we've done, is just to be open-minded and receptive. And I think the reason that's important is particularly in the tuning industry, which is kind of more my core, but I think probably the same could be said for engine builders. There tends to be sort of a secretive arrogance, I think I'd call it. And I kind of probably fell into this when I first got into the tuning industry myself. We were seeing some success, so you kind of think, oh, well, I know everything and I'm not going to share any of this with other people. And I fortunately quickly figured out that I absolutely do not know everything, nor will I ever. And there's people out there that always are going to know more about a particular topic than you can. Being open-minded, being prepared to listen rather than sort of being secretive, that's the way to create these relationships. And the other element that comes along with this is there's no need to be secretive. There's no magic here in tuning or in engine building. It's science. So you haven't created anything. People have been building engines and tuning engines for decades. And learning from that knowledge base is going to be such a good way of fast tracking your own knowledge and success. And I think that's the bit that a lot of the younger enthusiasts getting into the industry tend to miss. Do you reckon that sounds about right from your experience?
Yeah, for sure. A lot of people come in thinking they're going to change the world, and they've got this new idea, which is fine. Like, be keen, but be realistic that I've got good relationships with other engine builders in Auckland. So if I can ring anyone up and ask for a part, or ask if they have this, or can I borrow this machining, like, that's a good thing to have. You want that.
Absolutely.
And then, like you said, with like not having all the knowledge or thinking you have all the knowledge, if you think you've got it all, you definitely don't, because especially in tuning and working with cars and engines, you just continue learning. Every day you learn something new, whether it's small or a big learning curve. That's what keeps it interesting. So yeah, you'll never stop learning over the years to come.
I couldn't agree more. I've said this previously on the podcast. I mean, that fact that I am always learning, there's always something new to explore, some new technology coming out. That's why this far in, I'm still as passionate about the industry as I ever was. So I think that's really, really important for those who are new to it to understand. And I think the other element that comes into this is the bit of the Dunning-Kruger effect, where you come into something that you've got no previous knowledge on, and very quickly you sort of learn a little bit and you feel like you know it all. And the reality is that those who've been in the industry longer, that sort of sense of knowing it all quickly fades away, more to a point of you just don't know what you don't know. And that then brings down your guards, and you're more open and willing to talk to others and to absorb as much knowledge as out there. Let's move on to our last question, Tom. If people want to follow you, see what you're up to, maybe buy an HRE superstock engine, or maybe some of these products that you're going to release in the not too distant future, how are they best to do that?
So we're on all the standard socials. It's just Hughes Race Engineering. We also have our website. It's just currently being spruced up to suit all the new products that we're bringing out. So that'll be cool when that's done. But if not, we're pretty active with Instagram and Facebook and the latest builds we have to offer.
Perfect. As usual, we'll put links to your accounts in the show notes to make it super easy for people to find. Look, great to have a catch up on this podcast, Tom. Really do appreciate your time. Look forward to seeing how HRE sort of expands over time, and look forward to seeing what products you bring to the market.
Cool. Thanks for having me. It's been a good chat.
If you enjoyed this episode of Tuned In with Tom Hughes, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high-quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to the Mechanic88 from Canada, who has said, "Love listening to HPA. I'm a shop owner and technician from a daily driver shop in Nova Scotia, Canada, with a passion for technology and performance. Listening to the show is super informative and encouraging for my side project, a 1997 Evo 4G63 swapped all-wheel drive Eclipse." Well, thanks for the kind words there. Great to hear you're enjoying the podcast. And if you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now, remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.